Hello, algebra students. This is Coach Sharp. In this video today, we're going to talk about arithmetic sequences. Within arithmetic sequence section, we have 4 learning targets. The first learning target says, I can write an explicit arithmetic sequence formula to model a situation. The second learning target says, I can write a recursive arithmetic sequence formula to model a situation. 2 different ways of writing the formula or the equation, modeling the exact same sequence. We'll talk about the differences between the two. The third learning target says, I can write a recursive process that describes the relationship between 2 quantities. And then the last thing we're going to look at are how can I translate between recursive and explicit formulas. So before we talk about each of those learning targets, there's some definitions, some terms that we need to understand, be able to talk about. The first one of those is a mathematical pattern. And a mathematical pattern is nothing more than a repeated design or a recurring sequence. Something that's doing the same thing over and over and over. Within that, there's a sequence term, and that sequence term is a number that's in a specific position within that sequence. Now, I know we talk about terms whenever we talked about expressions earlier in the semester, but this is a different type of term. It's nothing more than a number that's in a specific location. If a sequence is recursive, then it repeatedly uses a procedure or a rule to obtain successive results. In other words, we do something to this number, and we get this number that follows it. We do that same procedure to that number that gets the number that follows it, and so on and so on. We just repeat that process. In an arithmetic sequence, there's a fixed number that's being added to each previous term to get the current term. To make that hopefully make a little more sense, if we have an arithmetic sequence and the first term or the first number in the sequence is 1, and we know that the common difference or what's being done to that first term is adding 3, then our sequence is going to look like this one here. We take 1 and we add 3. Sorry about that. Take our 1 and we add 3 and we get 4. Take our 4 and we add 3 and get 7. We take our 7 and we add 3 and get 10, and so on and so on and so on. Another example, if we write an arithmetic sequence beginning with a first term of 2, so we start with 2, that adds 5 to each previous term. So if 2 plus 5, 7, 7 plus 5, 12, 12 plus 5, 17, 17 plus 5, 22, and we can keep doing that all day long if they ask us to. That number that we add over and over and over to get the next term in our sequence is called the common difference. Again, it's just a fixed number that we add to each term to get the next term. Now, keep in mind that if our number that we're adding, if our common difference is a negative number, that negative number is going to make our sequence look like we're subtracting, because the numbers are going to get smaller as we go from left to right. And then this little note right here says that the common difference can be calculated by subtracting the first term from the second term. So if we're doing that on paper, Then we're going to have the second term is going to be on top, or is going to be on the left. And then we're going to subtract the first term, and that's going to give us our common difference. So an example of that. What's the common difference in the following sequence? 1, 4, 7. We know what that is. We did it a minute ago. But anyhow, we take our second term, which in our case is 4. We subtract our first term, 1. And so therefore our common difference is 3. And secondly, here another example. What's the common difference in this sequence? So again, we take our second term, -3. We subtract our first term, -7. -3 subtract 7 really is -3 plus 7, and that's 4. So our common difference is 4. And we can pick any two numbers in our sequence as long as they're beside each other, and we can check to make sure, hey, is this really what our common difference is? So in other words, right here, if we choose the 5, 5 plus 4 equals 9. So that's just a little check to make sure that your common difference is correct. Sometimes they'll give us numbers and ask us to write the sequence. Sometimes they'll give us the sequence and ask us to write the numbers. So a helpful rule, for lack of a better word, a helpful rule to help to use in this case is the arithmetic sequence rule. And the arithmetic sequence rule is this. It's written in function notation. So the function notation, they used capital letter A. You could use any capital letter you wanted to. Not sure why they use A. I use A and say that it means that you're going to find any term. So they use capital letter A to find any term. The lowercase a right here is the first term. That's the first term of our sequence. So if they give us the numbers and ask us to write the sequence, then we put our first number here. If they give us the rule and we're trying to actually write out the sequence, then we'll begin with whatever that number is. The n inside the parenthesis with the subtract 1 right here is the term number that we're asked to find. So if we were asked to find the 10th term, then we'd put a 10 right there in place of that n. We'd subtract 1, get 9, and then we would multiply by that d right there, and the d is our common difference. So if they gave us the rule, it'd be really simple to write the sequence. We'd start with our first term, little letter a, and we would add our common difference, and we would get our second term, whatever that is right there, and then we would just keep adding our d. Just repeat the process to find the actual arithmetic sequence that they wanted us to find.